Okay, so this is your third class period set aside for section 5.3. So again, the main thing would be this practice worksheet. I know you guys picked it up yesterday, but a lot of you focused on finishing up the bookwork first, which makes sense because that's the order I think you should do it in. But this worksheet gives you a good idea of how difficult the quiz will be, give you some idea of what things you may need to restudy or ask about. I did not mention this yet, I don't believe, but you might want to circle question F on the front page. Question F on the front page is a good question, but one part of that answer, when you go to check your answers, is not something that we would throw at you at the quiz. So you'll see what I'm talking about when you go and check your work on those questions. But the quiz you should expect about the same thing. 4 to 6 questions that ask you to solve, like the front of this, and 4 to 6 questions that want solutions from 0 to 2 pi, like the back of this. Now, I suspect some of you may have some questions ready to go on this. However, I do want people to actually try this as a practice quiz, and if I start going over some of the questions, then it's easy to think that you're prepared for it, and maybe you're not. So, if you would, try question A before you try question B. Try question B before you try question C. So then in a few minutes, when I open it up to questions, everybody's put eyes on question A, and if you need help with A, then you will at least know at that point. So I need you to finish that up. I need you to know what it is you need to study. And then 53 and 54 need to be turned into Google Classroom. That would be this worksheet and the book assignment. And then when I see you guys next Tuesday, we will have the 5.3 quiz. You do probably need to write down somewhere that the 5.3 quiz counts more than your other quizzes this year, because we don't have time to do any other sections and other quizzes and combine them into one test. So this one is kind of like a quiz and a part test in one. It'll be a 50-point major assignment. Yes?
When will be the 53 and 54?
I'm sorry?
I would like the deadline for 53 and 54.
For finishing what?
For finishing 53 and 54.
Well, 53 should be finished. 54 should be finished by the end of class, because if you have any questions on it, this is your chance to ask. But it needs to be in Google Classroom before we start the quiz on Tuesday. That's when you would lose some work points. But for you to get the help and the feedback and the assistance that you need, you really should be finished up with both of those by the end of the class. Okay, so again, I'm just assuming, I know you should have worked on some of this already, but I don't know that everybody has looked at question A yet. So let me set a timer, and here in a few minutes I will give you a chance to ask about question A or question B if you have it. And then after a while I open it up more to C or D, etc. Ellen's still out. 3. Amelia's still out. 2, 1, 2, 3, 1, 2, 1, 2. course, if you are a little bit ahead of everybody else, if you worked ahead and you finish with a lot of class time left, you might think about looking at your semester test review and seeing if there's anything left for you to work on with that. Remember, finishing that is part of the exemption process for our class, so. If you think you're going to be able to exempt, you probably want to have it done so that you can check it off for sure.
When do we find out if we're exempt?
I think they probably won't look at the applications to exempt until after the deadline, which is next Monday. So I don't know, maybe as early as Tuesday. The problem is that's only part of the check. They check to make sure you don't have more than one major discipline referral. They check your attendance, they check your tardies, all that kind of stuff. The thing that they won't check though is that you have an 80 in the class. So you'll still have to follow up with the teachers. And like for us, I wouldn't say you were exempt until I had your semester exam review in my hand too, so.
Well, you said we're not exempt until we give you the semester review.
For our class, you have to do the submission. The school has to say you met all the requirements, and then I still have to check to make sure you have an 80. And for pre-calculus, we also insist that you finish the semester exam review. So once all of those things are done, then I can officially tell you that you're exempt. But you're probably not going to know on Tuesday or all of that.
So I'm trying to look back in the book to remember. So solving is the 2 pi n, right, for every.
Because that implies that you want everything. Give me every solution to this.
And then this is only the things in the unit circle, right?
Yes. Because here, if you list answers between 0 and 2 pi, if you say plus 2 pi n, whatever the angle is, you add 2 pi, it's going to be bigger than 2 pi, so that doesn't make sense to do the plus 2 pi stuff on it.
Okay, so solving is plus 2 pi n, and then this is just in the unit circle.
Just one rotation.
All right,
One
thank you.
rotation in the unit circle. Okay. So as I said, making sure that you guys work these in order so that you've at least looked at the ones that are being asked about. So, based on how much time I gave you there, maybe question A or B, or maybe C for now. Does anyone need help with A, B, or C? Yeah.
On B, there's
Uh-huh.
only gonna be one solution,
Well, there's infinitely many
right? Or,
solutions.
yeah, but it's only gonna be in one spot, right?
It would be where cosine is -1, so it should be pi plus 2 pi n.
Right, yeah.
Okay, then let me. Is your question A, B, or C?
D.
Okay, then hold off, please. I don't know if everyone's had time to get to that one yet. Okay, let me give you a few more minutes, and then I will give you a chance for A, B, C, D, or E. I can't remember. It was somewhere over here. Yeah,
What's up? What's fault?
That red thermos thing right there. I think that was left in here from y'all's class.
I don't think that's mine. Oh,
Is it y'all? That red thermos water bottle thing? Okay. I thought it was during this class over here, but I could be wrong. Also, if you're working slower than everyone else, all of these are already worked out on the website except for I. I think no one ever asked about I because I think I put the exact same one in your notes. So I think that's why people don't ever need to ask that one. But just an alternative way. And of course, you're welcome to pull it up without the volume on if I'm going too slow for you. Okay, let me open it up to a few more now. So, how about A, B, C, D, or E? Any of those? D? Okay, on question D, probably the most common first step is incorrect. If you started off D by dividing both sides by sign, you're going to get some of the answers and you lost some answers. In our notes we talked about when you divide both sides by a variable, you lose some answers. We had one like this in your notes where when we divided both sides by x, we thought x could just be 1, but x could also be 0. And we actually had to solve it with algebra to get both solutions. So if you divided both sides by sign, I guess that is common, but you need to make some kind of a hint here not to do that. Instead, what you could do is you could add this over, and now both terms have a sign, so you can factor out a GCF. And now you have factors that multiply to 0, so you can set each factor equal to 0 and solve. I know where sign values are 0, so I don't need to do much more over here. But I don't know where secant values are -2. But it is okay to take the reciprocal of a side as long as you take the reciprocal of the other side. That's considered to be balanced as well. And cosine is -1/2 in 2 places. So those spots should be our solutions. So then it's just a matter of writing them consistent with the directions that they gave. So the long-winded way would be to just do 4 complete different statements. 0 plus 2 pi n, 2 pi over 3 plus 2 pi n, pi plus 2 pi n, and 4 pi over 3 plus 2 pi n. So that would be fine if you do that on the quiz. I don't know if when you check the solutions online if I wrote them out like that though. And if you want to condense them, you could do it in, you would need 3 statements. The red ones are equally spaced out, so you could combine both the red ones into this, but these blue ones are not equidistant. The distance from here to here is not the same as the distance from here to here. So those two won't condense with anything, and they'll just need their own statement. So I don't know. You only save 1 statement by trying to condense, but the most important thing there, and again, I don't know how to convey it other than to just bug you to death about it. If you divide both sides by sign, you probably got 2 of these answers and lost 2 of the answers. You're typically going to lose an answer or 2 when you divide by sign. Subtract it over and figure out another way. Okay, anybody else that's going to ask about question D? Need anything more specific? Okay, then what about others A through E?
E.
Okay. So what do you think the first step should be in E?
Getting the root to the other side.
Okay, you can do that if you want to, but I don't think that needs to be first. Okay, what did you want to do after that? Because I'm trying to see if...
Secant
Okay, that works. So you could change this into... When you say 1 over cosine, you mean cosine squared, because this is squared? Okay, and so since you did that, I'm guessing you made this do this. Okay, that's fine. I was thinking nothing wrong with this, and I don't know, this might end up being easier, But in my head, I was thinking about the first Pythagorean identity, and if I divide everything by a cosine squared, it looks like this. So I was thinking to either replace secant squared with tangent squared plus 1, and then I would have an equation that only has tangent stuff in it,
Okay.
or substituting tangent squared with secant squared minus 1, so I only had secant stuff. So again, your way may make more sense. I couldn't tell you yet, but so I'm guessing that your next step is to add these fractions together. Since there's already a common denominator there, that's an easy step to do. Okay, and then what?
I subtracted 2 over.
Okay, but this isn't a 2. This is a 2 over cosine squared.
Yeah, multiply cosine.
Okay, so sure, you could multiply both sides by cosine squared. That seems to be better because at least there's not fractions. But it looks like you're still going to get to the point where you're still going to have to use the Pythagorean identity at some point. So we can either change the sine squared into 1 minus cosine squared, or we could change the cosine squares into 1 minus sine squared. Shouldn't matter, but if you think one of those methods is going to be easier, then we can go that way.
Let's go make the cosine sign.
Okay. So instead of cosine squared, that would be 1 minus sine squared. Now, so your method, the way you wanted to start this question, as I said, there was nothing wrong with this mathematically, but I think if you had taken my suggestion up here, you probably could have cut out a couple steps. So this is probably not the most efficient way to do it. But now, going your route, we could distribute the 3. We've only got sine stuff, so that's a good sign. We could maybe add these 3 over and say we've got 4 of them over here. And maybe subtract 2 from both sides. And now it's starting to look like other questions. Looks a lot like question C almost. Divide both sides by 4. Take the square root of both sides. I'm going to highlight the plus or minus because that's what y'all tend to forget. You do have to be able to simplify the square root of a fraction in this section, and it looks like your solutions should come from when sine is positive 1/2 or negative 1/2. But I also know that right here in this step, when you multiplied both sides by cosine squared, that might create some extraneous solutions, because anything that makes cosine squared 0 is going to be undefined because we can't divide by 0. And the way I have it written right here, I can't see that, so I still need to check these answers. But pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And then because of the directions, I need plus 2 pi n. And if I think to try to check them, I think all of those are actually fine. I don't think any of them are extraneous this time.
We condense and make 2. Or
Oh, yeah. In fact, I don't know why I don't have 4 here. It either need to be 4 statements, or you could do 2.
Okay.
This one and this one are pi apart, and this one and this one are pi apart. I guess I should just make all my classes condensed so I don't have to verbalize every time.
Not a bad idea.
Can you do it with the first one, the one with the 10 squared pi plus 1, when you convert to the second to 10 squared?
How I came up with this one?
No, not how you can, like, can you solve it? using
Oh,
that?
sure. Yeah. The first and end of the question should be kind of similar. Well, maybe not the first step or 2, but okay, so since these two are not the same, that's where I know I need to change these somehow. So the way I suggested that you guys learn the 3 Pythagorean identities at the start of this year was to memorize the first one, be able to divide them all by cosine squared, or divide them all by sine squared. And you can find all 3 of them. And so it looks like this is the one that we need. So we could either replace secant squareds with tangent squareds plus 1s, or we could replace the tangent squareds with secant squareds minus 1. Again, if you think one way is easier than the other, then that's what you should go with. I am going to change the tangent squared just because I know tangent values are harder to deal with on the unit circle. So if I only have secants, I think that might be easier for me, but that's just my preference. So in the original question, instead of saying plus tan squared, I'm going to say secant squared minus 1. You okay with why I'm doing that? Okay. Now it's only secant squared stuff, so I can combine these like terms, combine those like terms, and now it's looking like some of the questions you've done in the book. Add the 4, divide the 3. Square root both sides. Of course, don't forget the plus or minus when you square root both sides. Still have to be able to simplify the square root of a fraction. And because this is secant equals this, I could take the reciprocal of the left side to make it cosine, as long as I take the reciprocal of the right side. And so, looks like the answers come from when cosine is positive square root of 2 over 2 and negative square root of, or I'm sorry, square root of 3 over 2. Positive square root of 3 over 2 and negative square root of 3 over 2. And that would be the same 4 spots we ended up with at the end. So, it looks like I worked a different question because the process was a little different, but I don't know. It may be a little bit shorter just because I went straight to this. Okay, so again, when you do part F, one of the answers that you'll check, you'll know looks kind of different. That we would not put that on the quiz, but otherwise, question F is a good question. So let me give a few more minutes, and then I will ask for questions A through G at that point. Try to have looked at and tried all of A through G in the next 5-10 minutes.
Do you have any extra copies of the notes from Tuesday?
Blank copies?
Yeah.
Yeah, all my extra copies, one of those baskets by that table at the front says pre-cal handouts. You just need to know what number it is in the binder. Did you find what you needed?
Is it?
Okay, I think I'd said questions A, B, C, D, E, F, or G. So any of those that you would like me to go over with you? G?
Yes, sir.
Okay. G has different directions. Just wants us to list the answers between 0 and 2 pi. And what angle can we take the sine of, add 1 to it, and get cosine. And to me, this is kind of a special case here because of this +1. This is one that in our notes I said I wouldn't even bother with the algebra because the algebra is going to be a lot of work and you're going to need to check all of your extraneous solutions anyway. So since on the unit circle, sine is all the y values and cosine is all the x values, the only 4 places where sine and cosine are separated by 1 would be these 4. So I would just guess and check each of these 4. Add 1 to sine, see if it equals cosine. If I add 1 to sine, it does equal cosine. If I add 1 to sine, it doesn't equal cosine. If I add 1 to sine, it doesn't equal cosine. And if I add 1 to sine, it does equal cosine. Looks like 0 and 3 pi over 2 would be your 2 solutions. Now, if you want to do it algebraically, you're going to have to square both sides. And of course, I don't discourage you from trying that. It would be a good challenge for you. It's just not what I'd recommend for you to do on your quiz. If you see one that just says +1 or -1, then just check the 4 quadrantal angles. Those are the only spots they're separated by 1. Okay, others, A through G.
A to F.
F, sure. Okay, so cosecant squared is equal to 3 cosecant plus 4. Okay, so my first observation is I need to treat this like a quadratic because it's got an exponent of 2. So we need to move everything to the left or to the right, just like we would with the quadratic. And then just like a quadratic, we could try to factor this. Remember that you can rewrite this with x's if that helps you do the factoring. Same idea. And so if I set this equal to 0 and solve, looks like some solutions are going to come when cosecant equals 4, which is the same thing as when sine is 1/4, reciprocal of both sides. And then over here, if I solve this for 0, it would be when cosecant is -1, which is the same thing as when sine is -1. Reciprocal, and reciprocal of -1 is still -1. So this part of the question is fine. This one would be fair game for the quiz. Sine is -1 down here at 3 pi over 2. The directions say solve, so that's why I put the +2 pi in. You okay with that? Okay, this is the part that we would not put at you on the quiz. In fact, we always talk about taking it off this worksheet. But is there an angle that has a sine of 1/4? Yes, there is, because sine exists everywhere from -1 to 1. It's just that we don't memorize that spot. We memorize when sine is 0, we memorize where sine is 1/2, we memorize where sine is square root of 3 over 2. We don't memorize where sine is 1/4. But sine is the y value. So if 1/2 is at 30 degrees, 1/4 is close to 15. It's not exactly proportional, but for our sake, do you see why both of these would need to have a sine of 1/4? If this is about where sine is 1/2, then the sine of 1/4 is somewhere less than that. So this answer, since I don't know the name of that angle, we can still refer to it. We would just say the angle that has a sine of 1/4. And in mathematics, the way we can do that without knowing the name of the angle is by saying inverse sine of 1/4. That's saying the angle that has a sine of 1/4. And then technically, there's another one over here because these two both have the same y value, so they both have the same sine value. This angle is almost at pi. It's at pi, take away however big this little bitty angle is. So that's where these two things are coming up on the answer sheet. So those angles exist. We just don't have a name for them. So in mathematics, that's the best thing that we can do. But for about the 6th time here, just to be clear, we will not put this type of, we will not expect you to give that sort of answer on the real quiz. You don't have to worry about studying that, but it's good for you to understand. Okay, let me do one more timer here, and then I will give you a chance to ask H, I, J, or anything else that I moved on too quickly from. So try to work your last couple and make sure there's nothing else you need to ask about. Also, just a heads up, I don't think this is gonna matter to us, cause I don't think it's gonna happen this period, but there is another fire drill today, and it's scheduled sometime between 12 and 4. And again, I suspect it's not gonna be during this class period because lunches are going on, and I think they just won't ever do it during lunchtime. But there is supposed to be one this afternoon, so there's always a chance it could go off while you're in here. We have to do one a month, so that's some reason they just happened to plan 2 this week. One at the end of November and one at the beginning of December. Okay, it's been a few more minutes. So, questions H, I, J, or anything else I went over too quickly? Anything else I can help with?
Can you do H?
Sure. H is cosine of 1/2 theta is equal to negative square root of 2 over 2. So this is what they refer to as a multi-angle. So in the notes and the bookwork, I had suggested pretend like it's not 1/2 theta, pretend like it's just a regular 1 theta, and then work it this way. Cosine is negative square root of 2 over 2 at 3 pi over 4 and 5 pi over 4. And so, let's see, this one's solutions between 0 and 2 pi. So if I try to write out the solving solutions, that would be 3 pi over 4 plus everything coterminal and 5 pi over 4 plus everything coterminal. The one extra thing you need to consider, though, is that our question wasn't really a theta, it was a 1/2 theta. So I haven't really solved for theta, I have solved for 1/2 theta. But all that's really going to do is add one extra step to get these solution equations. I want to multiply this by 2 to make it theta, but that means I have to multiply everything by 2. And then same thing with this one. Just make this 1/2 theta equals to just theta equals, multiply everything by 2. And then this can be your solution if the directions say solve. But on the back, our directions are not solve. They say give the answers between 0 and 2 pi. So we need to use these as a way to extract all the answers. This says one answer is 3 pi over 2. And it says you get another answer if you add 4 pi to that. But if I add 4 pi to that, it's going to be way bigger than 2 pi. So for this first equation, the only thing between 0 and 2 pi is 3 pi over 2. And then if you look down here, you're going to be tempted to say this one, but 5 pi over 2 is actually bigger than 2 pi. This is 2.5 pi. So that's already too big, and if I add 4 pi to that, then it's even bigger than too big. So looks like the only solution between 0 and 2 pi would be 3 pi over 2.
If we put 6 pi before, would that?
That's the same thing, yeah. Okay, anything more specific about H before it's gone? Okay, then what about I or J or any of the others? Yes.
Okay.
J? Okay, so the only thing you can do with J is you could divide both sides by 4, and then you're going to get this, and you're either going to be stuck forever or you're going to be finished in about 2 seconds. because if you remember, the range of sine is -1 to 1, and or you think about the graph of sine only goes up to 1, down to -1, or you think about on the unit circle, sine can get as big as 1, or sine can get as small as -1. Sine can never be -3. So, not possible based on the directions it wanted me to say no solution. There's no angle that has a sine of -3. Sine is opposite over hypotenuse, so the hypotenuse would have to be bigger than the opposite, which doesn't make sense.
And this sheet would be the same format as the quiz.
Quiz will look very similar, yes.
Okay, same amount of questions.
Give or take 1 or 2, yeah.
Okay.
I mean, I'm not saying like how you work question A is going to be how you work question A on the quiz, but similar format, should be similar difficulty. Anything you missed on this practice quiz is exactly what you should look at and review before the real quiz. Okay, well, if y'all do find other questions, there's still plenty of time to ask here. Assuming that we don't have the fire drill go on off on us, we've got about 22 minutes left. So, if you do find a question you'd like some help on, either bring it up here to me or raise your hand and call me over. Either one, I would be happy to come help. Also notice though that you do need to have 53 and 54 turned into Google Classroom. So if you're finished with those and you're sitting there doing nothing else, you might as well turn those in so that you don't run the risk of losing them and having to redo them. And of course, if you don't feel like you're ready to sit down and take the quiz, you should use these last 20 minutes to chip away at your studying.